Okay, welcome back. Today's Module 1, Day 17, the last of our notes for this unit. Keep in mind that Thursday we're going to have a quiz. That is on the 27th. And we're also going to have a test on the 1st of September, which is next Tuesday. Again, if you're at home, then you will be taking, or you'll have to schedule your quiz or your test at a specific time. So stay tuned for some emailed instructions. Okay, let's talk about reference angles. The reference angle, basically, if you have an angle here, so there's my initial, and it opens to, let's say right here, I don't know, 115 degrees, that's this angle. Then my reference angle is actually this theta right here. It's the closest or the shortest angle measure to the x-axis, So even though my angle is 115 degrees, my theta is going to be that difference between 180 and 115. So, for instance, the reference angle for 10 pi over 3. So let's just look at where 10 pi over 3 is. So this is 10 pi over 3s. So we've got 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. 6 pi over 3. Then we've got 7 pi over 3, 8 pi over 3, 9 pi over 3, and 10 pi over 3. Another way that I could find what this is I could actually subtract or find coterminal angles. So I could take 10 pi over 3 and subtract 6 pi over 3, and I end up with 4 pi over 3, which is, of course, right here. So the reference angle is this angle, the shortest distance to the x-axis right here. Shortest distance. So that's right here. And that theta, we use it as a theta prime, so we've got this little apostrophe there, represents pi over 3. That is my reference angle. We use it when we're setting up these triangles in the coordinate plane to solve or evaluate the trig values. And we'll use them in other places as well. So the reference angle is very important. So just to clear that up, the reference angle is the shortest angle measure from the terminal side to the x-axis. Okay, what about 322 degrees? Well, I know that this is 270 and this is 360. So 322 is somewhere in this area, maybe. Okay, so that's 322 degrees. So the distance between this terminal side and the x-axis is right here. So I could take 360 and I could subtract 322 degrees and I get 38 degrees right here. So theta prime, or my reference angle, is 38 degrees. Now, I don't say that it's negative because, again, the reference angle it's always a positive angle measure. So, reference angle, a positive angle measure. It's just basically giving us the angle distance from the terminal side to the x-axis. Okay, evaluating non-acute angles. Okay, so here we have negative 495 degrees. Now, I could try to kind of go around the circle. I know it's more than 360, so I would go negative 360 and then some more. So let's see here, 495 minus 360, so I would go another negative 135 degrees. Okay, so here would be my terminal side. But instead of doing that, I could just add 360 and then add another 360 to get a positive angle. So 495, negative 495 plus 360 again is 225 degrees. Okay? So that's this angle right here, 225. If I were to take the short way. Well, the short way would be negative 135. Okay, so what I'm trying to evaluate here is this measure for these values for the 6 trigonometric ratios. Again, this refers to my reference angle, the shortest distance, the shortest angle measure, from the terminal side to the x-axis. Okay, so to find that theta, I would just take 225 and subtract 180. That's going to leave me with 45 degrees here. So my reference angle is actually a 45 degree angle. And for me to evaluate, if I know that's 45, then this right here would be the square root of 2 over 2 and the square root of 2 over 2 in the unit circle. So to find all 6 ratios, sine of theta, cosine of theta, tangent of theta, I just have to go back and look at my, I believe that was 5 pi over 4. All right, so sine is the square root of 2 over 2, cosine is the square root of 2 over 2, tangent is going to be 1. Oh, I'm sorry. These are both negative. Because we are in quadrant 3, these are both negative. Cosecant would be negative square roots of 2, negative square roots of 2, and this would also be a positive 1. Okay, so non-acute angles just means that they're obtuse. Okay, they're bigger than 90 in positives or negatives here. Okay, now evaluating using the trigonometric identities. So as we evaluate, we're going to use our trig identities. Now, do we know anything about cotangent and sine? Is there something that relates them together? If it tells me the cotangent is negative 3, then I could say, well, that's negative 3 over 1. Also, I know a trig identity that states that 1 plus the cotangent squared theta is equal to the cosecant squared theta, and cosecant is the reciprocal of sine. So without graphing anything, I have found an identity that could link these two values together. So I'm going to take 1 plus parentheses negative 3 squared, and that should give me cosecant squared theta. Okay, that's going to be 1 plus 9, which is 10, and 10 is equal to cosecant squared theta. So when I go to take the square roots, I have that the square root of 10 is equal to the cosecant of theta. Remember, that's that's over 1. So my sine of theta would be the square root of 10 over 10. So if I reciprocate that, I get 1 over the square root of 10, which simplifies to the square root of 10 over 10. Now this is purely algebraic. So knowing these identities in that identity page, it's all algebra. So if you loved algebra, this is right up your alley. Okay, what about cosine and secant? Well, cosine and secant are reciprocals, right? So the secant of theta is the reciprocal of cosine. And so I've used a reciprocal identity. And then here I used a Pythagorean identity. All right, so your practice is page 290 to 291, number 35 through 125. Again, you start by focusing on the odds, and then you can work towards the evens. All right, that's it for today. Thank you.